Hello, welcome to my video on factorizing quadratics. I'm going to start with quadratics with two terms, including the difference of two squares. Then I'll move on to factorizing quadratics with three terms, first where the coefficient of the x squared term is 1, and then where the coefficient of the x squared term is greater than 1. One purpose of the video is to teach you how to simplify algebraic fractions, like the exam-style question on the board. Many candidates would be unable to factorize the denominator, and some would make mistakes with the numerator. Being able to factorize quadratics also helps with many other areas of algebra, for example solving quadratics and solving quadratic inequalities. The standard form of a quadratic is ax squared plus bx plus c, where a, b and c are numbers. A cannot be 0 and x is a variable. I will show you how to factorize the following 9 equations. Example 1 is a two-term quadratic, and when we factorize these, we must look for common factors. Immediately, we can see that x is a common factor. Can you also see that as 6 is a factor of 72, we can take 6x out of both terms. This will factorize to 6x times x plus 12. Looking at example 2, there are no common factors. What we have though, is two square numbers with a minus sign between them. This is called the difference of two squares, and these quadratics always factorize to two brackets, x plus the square root of the number, times x minus the square root of the number. In this case, x plus 1, times x minus 1. Moving on to example 3, another two-term quadratic. First look for common factors. The only common factor is 3. Factorizing gives 3, times x squared minus 9. X squared minus 9 is the difference of two squares, so we can factorize again, to 3, times x plus 3, times x minus 3. For three-term quadratics where a equals 1, the technique each time is basically the same. They factorize to two brackets. You then look for two numbers to put in those brackets that multiply together to give c, and that add together to give b. I'll guide you through the 4 different examples where b and c have different signs. Let's start with example 4, x squared plus 7x plus 12. We factorize to two brackets, putting an x in each, which gives us the x squared term when we multiply out our brackets. As both b and c are positive, you need to find two positive numbers, one to put in each of the brackets, so that when these numbers are multiplied together the result is 12, and when they are added together the result is 7. Pairs of positive numbers that multiply together to give 12 are 1 and 12, 2 and 6 and 3 and 4. 3 and 4 when added together make 7, and when multiplied together make 12, so the equation factorizes to x plus 3 times x plus 4. For the next example, consider when the x term is positive, but the number is negative. We factorize to two brackets, putting an x in each, which gives us the x squared term when we multiply out our brackets. This time c is negative and b is positive. You need to find two numbers, one to put in each of the brackets, that multiply together to give minus 20, as c is minus 20, and when added together make 8, as b is 8. Numbers that multiply together to give minus 20 are 1 and minus 20, minus 1 and 20, 2 and minus 10, minus 2 and 10, 4 and minus 5 and minus 4 and 5. Looking at the various options, you can see that 10 plus minus 2 equals 8, so the equation factorizes to x plus 10 times x minus 2. For the next example, consider the situation where both the x term and the number are negative. We factorize to two brackets, putting an x in each, which gives us the x squared term when we multiply out our brackets. This time b and c are negative. You need to find two numbers, one to put in each of the brackets, that multiply together to give minus 6, as c is minus 6, and when added together make minus 1, as b is minus 1. Numbers that multiply together to give minus 6 are 1 and minus 6, minus 1 and 6, 2 and minus 3, and minus 2 and 3. Looking at the options, 2 plus minus 3 equals minus 1, so the equation factorizes to x plus 2 times x minus 3. For the final example, let's look at the case where the x term is negative, and the number is positive. We factorize to two brackets, putting an x in each, which gives us the x squared term when we multiply out our brackets. In this case, remember that two negative numbers multiply together to give a positive number. You need to find two negative numbers, one to put in each of the brackets, that multiply together to get 9, as c is 9, and when added together make -10, as b is -10. Negative numbers that multiply together to give 9 are -1 and -9 and -3 and -3. -1 plus -9 equals -10, so the equation factorizes to x minus 9 times x minus 1. Congratulations! You have mastered factorizing two-term quadratics and three-term quadratics where the coefficient of the x squared term is 1. Let's move on to three-term quadratics where the x squared term has a larger coefficient. Example 8 has an x squared coefficient of 2. We factorize to two brackets, putting 2x in one bracket and x in the other, which gives us the 2x squared term when we multiply out our brackets. As both b and c are positive, you need to find two positive numbers, one to put in each of the brackets. As before, we need to find two positive numbers that multiply together to make 6, as c is 6, but this time we need to work out two numbers, where 2 times one number plus the other add to 7. Positive numbers that multiply to 6 are 1 and 6 and 2 and 3. As 2 times 2 plus 3 is 7, the equation factorizes to 2x plus 3 times x plus 2. Can you see that we need to put the number 2 in the bracket opposite the 2x term, and the number 3 in the bracket opposite the x term? This ensures that we get 2 times 2x plus 3 times x, which gives 7x when we multiply out the brackets. Awesome! You are now ready to answer the exam-style question I showed you at the beginning of the video. We have already factorized both the numerator and the denominator. Go back to example 6 if you need help factorizing the numerator, and example 8 if you're struggling with the denominator. Can you see that the x plus 2 bracket appears in both the numerator and the denominator? These cancel out to leave the much simpler fraction as shown, the answer to the question. The final example is the most difficult. 4x squared plus 4x minus 15. This will factorize to two brackets, but in this case, we have to use numbers that multiply to the x squared coefficient, or a, which is 4, and numbers that multiply to c, minus 15. These numbers need to multiply and add together to give us the coefficient of x, or b, in this case 4. It is not too difficult. You just have to be careful and methodical. Numbers that multiply to 4 are 1 and 4, 2 and 2, and 4 and 1. Numbers that multiply to minus 15 are 1 and minus 15, minus 1 and 15, 3 and minus 5, and minus 3 and 5. Multiply these together in pairs and add to see if the answer is 4. You can see by common sense that 1 and 4 won't give an answer of 4 with either 1 and minus 15, or minus 1 and 15. The same is true of 1 and 4, with either 3 and minus 5, or minus 3 and 5. None of these combinations give the required answer. You can also see that 2 and 2 won't give an answer of 4, with either 1 and minus 15 or minus 1 and 15. Let's multiply 2 and 2 and 3 and minus 5. 2 times 3 is 6, 2 times minus 5 is minus 10. If we add these together, we get minus 4. However, if we change the sign by using 2 and 2 and minus 3 and 5, we get minus 6 plus 10, which is 4, the answer we are looking for. So, the equation factorizes to 2x plus 5 times 2x minus 3. Thank you for watching my video. I hope you can now factorize quadratics. You should feel confident you can apply these skills to simplifying quadratic fractions like the worked example I showed you. This will help with exam questions and revision. If you have found the content useful, then please subscribe to my channel, not forgetting to switch on alerts so you know when I release more videos.